Thanks so much for having me. As already alluded to, I'm going to talk about something like market design for online trading platform, especially about the role of transparency versus intransparency of transaction costs in financial markets. So the motivation is as follows. In today's financial markets, the classical financial players like the New York Stock Exchange, they face increasing competition from online trading platforms like Robinhood, eToro, Charles Schwab, E-Trade, claiming that they, on the one hand, democratize and simplify market access. And recent studies have found that these markets are only going to grow in size over the next decades. And also that around 80% of retail traders as of now already conduct their trading activities through online trading platforms instead of going to a traditional financial exchange. Now, when it comes to the competition for retail traders, one of the key cornerstones centers around transaction costs. Traditional financial exchanges like New York Stock Exchange, heavily regulated by the SEC, have to adhere to transparent and extensive transaction cost documents. Here you can see a page of a 30-page excerpt of the regulations of transaction costs on the New York Stock Exchange. On the right-hand side, well, most online trading platforms claim that they are zero commission. So they claim that they don't charge you any transaction costs at all. So as economists/computer scientists, we know that there's rarely such a thing as free lunch. So where's the catch? Like, they need to monetize somehow. Now, the catch is as follows. The truth behind zero commission models is that online trading platforms like Robinhood, they monetize via a practice called payment for order flow. Now, what payment for order flow is that Robinhood basically sells the order book to a third-party market maker, which is a financial institution that buys or sells financial assets. So these financial market makers, they pay Robinhood on the side for the privilege to execute the trades and to choose the bid-ask spread, so the buy and the sell price at their own discretion. So there's a divisive debate going on because it's long been acknowledged that these payment for order flow is kind of like a two-edged sword, because on the one hand, market makers, they provide immediacy and liquidity of trade. But because market makers can basically adjust the bid-ask spread at their own discretion, you can often incur something like a hidden transaction cost, where the hidden transaction cost is the price you get at a market maker versus the best available price you could get on a traditional exchange. Like the SEC has been heavily trying to regulate that in the US, but due to lobbying efforts on the basis of Robinhood, to this day, it is still legal. For example, in Europe, the payment for order flow method is strictly forbidden. So for this talk, what I'm going to be looking at is exactly these hidden transaction costs and how the transparency versus intransparency of such transaction costs are going to influence the strategic incentives for traders, revenue for the market platform, and market efficiency overall. So coming directly to the model, in the paper, there's going to be a more extensive model, but for today, I'm going to show you a very simple and stylized example. So we're going to work with a very simple demand and supply model where we have a unit mass of buyers and sellers who are going to be interested in buying or selling a financial asset. And for today's talk, you can think about unit demand and supply. So the densities of these distributions are equal to 1. Now, traders are going to submit limit orders to the market, where a limit order for a buyer is going to specify the maximum price at which they're willing to buy a financial asset. So as soon as the price hits that value or a value below that, the limit order is going to be executed, and similar that's going to be for the seller. So when we aggregate these limit orders, we get the classical picture of a demand and supply model. So the demand at price P is going to be the mass of all traders with a limit order that has a value strictly or greater than P, and similar supply is the mass of all sell orders with a value less or equal than P. And for today's talk, the assumption is going to be that those are strictly and monotone and differentiable functions. So for the rest of the talk, I'm going to illustrate all of my findings for the simple model where you have a linear demand and supply function. Now note that in a classical financial markets, it's going to be finite. So the limit order book is going to be step functions, but we can approximate that in a limit and for a large order book. So what I'm going to be interested in is, on the one hand, the market clearing price, which is simply the Eurasian equilibrium, so the intersection of demand and supply. Now, those are the traders. Now, what is the market platform going to do in my model? The market platform is going to observe the order book, so the demand and the supply schedule, and it's going to set a bid-ask spread, so a buy price and a sell price for the asset, and the difference between the two is what I'm going to call the bid-ask spread. Now, given that bid-ask spread, the market platform is going to execute some buy and some sell orders, where the only condition is that the mass of executed orders needs to be the same for both market sides so that you can actually match buy and sell orders and facilitate trade. Now, active buyers are going to pay the buy price. Active sellers are going to receive the sell price, as is the case in the financial market. And the platform revenue is thus the bid-ask spread times the trading volume. So in the case that I put up here, the revenue can be basically illustrated as this rectangle that you can fit under the demand and the supply curve. Now, the area to the left and to the right of the revenue, so the small triangles, are going to be the surplus for the traders. And the sum of revenue and surplus is what I'm going to be calling the gains of trade. And now the area, the triangle on the top, is what I'm going to call the dead weight loss. So basically how much efficiency you lose by imposing a bid-ask spread. And the efficiency is going to be the realized gains of trade divided by the maximum gains of trade, which is simply the entire rectangle under true demand and supply. Now, I was saying that I'm going to be interested in transaction costs, and these transaction costs are going to come into play on how we're going to set the buy and the sell price. But before I'm going to talk about transaction costs, I'm going to be introducing a dynamic market model, which is as follows. Now, traders are going to be arriving at discrete steps in time, so 1, 2, up to infinity. And I'm going to be assuming that at those time steps, there's going to be a constant incoming value distribution. So the same demand and supply curves are going to be arriving to the market each new trading day. Now, the market platform at time step t is going to set buy and sell prices and execute some set of orders. But now what this means is that you're going to have some unexecuted orders in the market, which are basically all buy orders which are strictly below the buy price and some sell orders that are strictly above the sell price. This is now what I'm going to call the excess demand and supply at time t. And I'm going to be assuming that, as is the case in financial markets, these unexecuted orders are going to stay in the order book. So at time t plus 1, the demand at time t plus 1 is going to be the newly incoming demand plus an epsilon fraction of the excess demand, where the epsilon is simply going to be the probability that an order is going to remain active for the next trading round. And I'm going to assume that the objective for a platform is going to be revenue maximization. And to really focus on the key trade-off that the transaction costs are going to bring, I'm going to talk about myopic per round maximization, but all of the results are going to hold true if I'm going to talking about revenue maximization in the long run. And for the long run efficiency, I'm simply going to look at the average efficiency of the market over time. Now, how are we going to set the buy and the sell prices? This is what I'm going to call by transparent versus hidden transaction costs to the business model at financial exchanges like New York Stock Exchange versus at market makers. So transparent transaction costs, I'm going to model as the buy and the sell price. They're going to be set as ex ante communicated functions of the market clearing price. So the example that I'm going to be using is, for example, a constant transaction cost that, given that the equilibrium price at time t is going to be P, the buy price is going to be P plus C, and the sell price is going to be P minus C. So the bid-ask spread in that example would be 2C. Now, in the paper, you can allow for more general functions which simply need to be analytically well behaved in terms of continuity and monotonicity, but all of the results will hold for any such transparent transaction costs. Now the allocation is going to be, I'm going to execute all buy orders that are strictly greater than the equilibrium price and all sell orders that are strictly below the equilibrium price. Now there's one small caveat, because the transaction costs are added ex post to the market, traders need to take that into account, because if I put in a value of 100, and I know that I'm going to pay a $10 transaction costs, I need to shift my value down to 90. And I'm going to be looking at these traders' behavior of adjusting this transaction costs to account, adjusting the values to account for transaction costs. For constant fees, this is going to be simply an additive shift. For more general fees, you can actually analytically solve what the optimal response of traders to transaction costs is. So what's going to looking like is as follows. You see the true incoming demand and supply, which is the solid lines. Traders are going to adjust for the transaction costs, giving you the net demand and supply. The net demand and supply, where it's intersecting, is going to be the equilibrium price, and you're going to execute all buy orders in red that are strictly above the equilibrium price, and all sell orders below, which is the blue line, which are below the equilibrium price. And what the traders involved in trade are going to pay is that function of the market clearing price that is ex ante communicated. I want to iterate again, this is the way that it works in financial markets, where for some assets, the function would be a percentage of the market clearing price. For other assets, it's a small constant fee. Now, how does this differ from the hidden transaction cost? I'm going to be modeling hidden transaction costs as buy and sell prices that are chosen ex post without any commitment. So this means that the market platform is going to observe the demand and supply schedule and set the buy and the sell prices without any commitment to the equilibrium price, where the only constraint is that the demand at the buy price needs to be equal to the supply at the sell price in order to be able to match trades. The allocation is going to be the same. You're going to execute all buy orders above the buy price and all sell orders below the sell price. And for this, because you don't need a trader net value adjustment, so what you're going to see is that the solid revealed demand and supply is not a true demand and supply. You're going to choose the buy price and the sell price, or equivalently the spread, and you're going to basically execute all trades as mentioned before. So this is the model that I'm going to be talking about. So in the next slide, I'm going to be comparing transparent versus hidden transaction costs, first in a static market and then in the dynamic market. So first in the static market with the following result. There's actually an equivalent stating that the same set of market performances in terms of revenue or efficiency is achievable for hidden transaction costs and transparent transaction costs. Another reason is if you focus first on the right-hand side, what you can actually achieve is by setting the bid-ask spread, the revenue is given by any rectangle that you can fit under true demand and supply, and this is also fully gonna be specifying the efficiency. So by simply choosing the right bid spread, you can basically have this one-dimensional set of market performances by scaling up and down that rectangle. Now, for transparent transaction costs, it's a bit more tricky, and it's a non-straightforward result that actually the same set of market performances is achievable because the rectangle from transparent transaction costs is going to be the same. It's going to be the rectangle that fits under true demand and supply. Now, why is that surprising? Now, recall for transparent transaction costs, you never actually see the true demand and supply. But the optimal response of traders to the transaction costs will actually turn out to be the one such that the buy and the sell price actually matches exactly the point where they intersect true demand and supply. This comes out of a previous paper that I have with a couple of co-authors. So what is the main takeaway from the slide? Is that if you just look at a one-shot simple demand and supply setting, Robinhood would like to tell you nothing funky is going on with our hidden transaction costs. By actually not committing to transaction costs ex ante, you're not losing anything. You can achieve the same as you could if you were to commit ex ante to a transparent transaction cost structure. So why would you regulate us? Turns out that in a dynamic market, now this drastically changes. First, the baseline for transparent transaction costs, the theorem is going to be that in my dynamic market environment where demand and supply arrives over time, prices are going to be stable. Why is that the case? On the first round, you have your transparent transaction costs. Basically, you're going to clear the market with some revenue. But in the second round, the way that excess demand and supply builds up, because you cleared all of the orders up to the equilibrium price, excess demand and supply, so where the demand and the supply curve gets steeper, only builds up after the equilibrium price. So it doesn't change the equilibrium price. And because the buy and the sell price was an ex ante chosen function of the equilibrium price, actually it turns out that the bid-ask spread and the buy and the sell price are going to be stable over time. So in that market environment, transparent transaction costs would lead to a stable bid-ask spread. Now for hidden transaction costs, this is not going to be the case. They're going to be recurrent price cycles. Now, what is the reason behind that? Now, on the first day, you're going to clear the market according to what you deem optimal given one demand and supply curve. So you're going to choose some bid-ask spread that maximizes your revenue. Now, on the same day, because excess demand and supply builds up, actually you can profit from slightly lowering your spread in order to clear more trades. And so you actually want to decrease your spread versus the first day in order to actually increase your revenue. Now, what you would do on the third day is, well, now excess demand and supply is built up for the first 2 days. So actually you want to lower your spread even more in order to basically profit from the buildup in the order book from the first 2 days. Now, on the fourth day, your spread was already so narrow, so you cleared so much of the market that it turns out you actually want to revert back down to your baseline spread. So you're going to get a cycle of length 4. And for this talk, I won't have the time to talk about it, but actually you can analytically solve that and get a recurrent price pattern of how the bid-ask spread is going to evolve over time in this market. And it's a pretty cool formula. I'm happy to talk to you more about afterwards. So basically the main takeaway is that the hidden transaction cost, the failure to commit to a transparent function before, is going to add, in comparison to transparent transaction costs, unnecessary volatility in the market. So what I'm going to be talking about next is platform competition. So from the eyes of a trader, if I were to know about these cycles, which market platform would I choose? And I'm going to assume the traders are going to have some beliefs about the market. So for today, I'm going to assume that they know the incoming value distributions of demand and supply. This means for transparent transaction costs, because the spread is going to be stable, they're going to have some deterministic belief, sigma t, about what the spread in the market is going to be. Now, this is again in line with what happens in traditional financial markets. You can actually see the spread that is currently in the market. Versus for the hidden transaction cost, traders will form some beliefs about the cycle. So what I showed you on the last slide is, traders understand that there is going to be some sort of cyclical behavior, but because the current spread is not announced on these online trading platforms and for these market makers in advance, you don't know at which point of the cycle you are. So I'm going to model it via some beliefs. The traders basically form beliefs about how likely it is to be at a current point in the cycle. So from the point of a trader, it's kind of like determining whether you want to have a deterministic lottery or you want to have a proper lottery. And so because we're talking about lotteries, we need to talk about risk aversion. And the example I'm going to be using today is simply constant absolute risk aversion, so an exponential utility function. And note that a smaller spread means a smaller buy and a higher sell price, which is why we have the 1 minus. So a smaller spread is actually what traders want in that kind of market. And the equilibrium notion that I'm going to be using is a pair of a deterministic spread and beliefs about the cycle, such that in expectation they're the same. So this is the point. This is the level of transparent transaction costs that would make traders be indifferent whether to go to the traditional exchange or to the market with hidden transaction costs. Now, the theorem is that such an equilibrium exists. It's going to be sub-monopoly pricing, that is transparent transaction costs need to be charged at a level that is not the revenue maximizing one. Why? Because the revenue maximizing one is the baseline that you get in a market with hidden transaction costs, and the cycle are actually always price improvements. So if you want to have an equilibrium, the transparent transaction costs need to be somewhere strictly in the interior of these price cycles in order to be in equilibrium. Well, so I'm an economist, I'm going to do some comparative statics. This transparent transaction cost is going to be strictly increasing in the risk aversion. This means a higher level of risk aversion. Traders are more afraid of the uncertainty of the price cycles. So the market with transparent transaction costs can get a way of charging them at a higher rate. And because higher transaction costs means less efficiency, this means that the efficiency of the market with transparent transaction costs is going to be decreasing in the risk aversion. And lastly, there's an interesting crossover point, meaning that for high levels of risk aversion, the market with transparent transaction costs is on average actually less efficient than the one with hidden transaction costs. And if you decrease the risk aversion, this is actually going to turn around, and the market with transparent transaction costs is going to be more efficient. There's going to be an extension in the paper where traders have a continuum of risk attitudes, and the same equilibrium existence result will hold. And we're going to have a market segmentation where traders that are more risk averse are going to choose transparent transaction costs, and traders that are less risk averse are going to choose hidden transaction costs. Now, I don't have as much time as I want to talk about strategic market entry, because for now I assumed unsophisticated traders who truthfully report their valuations, which is optimal in a one-shot market setting. But actually, is there a way that you can exploit these price cycles? And my brief answer, and I'm happy to tell you more about it afterwards, is yes, there is a way. And the way is via strategic market entry. Now, the point for the hidden transaction costs is you don't see the current spread. So strategic market entry doesn't mean, okay, I'm going to wait until the spread hits a good point in the cycle, because I don't see that in advance. But what I can do is I can put in a more aggressive limit order that only gets executed once I hit a good point in the cycle. And via this aggressive price guessing, actually, if all traders guess this most aggressive price, I would get a new demand and supply curve with a discontinuity there. And the last meta theorem is that strategic market entry, on the one hand, is irrelevant for transparent transaction costs because the spread is stable anyway, so I can't gain anything. But for hidden transaction costs, it can lead to market failure. And what is the reason? Now, traders guess the lowest spread, but after that spread, excess demand and supply is still going to build up. So what you're going to get is new price cycles with a new baseline lowest spread. But now traders should guess that new minimum. So actually, via iterative reasoning, you can show that the only Bayesian-Nash equilibrium in that market is the one where all traders fully guess the equilibrium price, which is going to lead to zero revenue for the market platform. And if they have some misspecified beliefs, you could even get to market failure. So the conclusion is as follows. Like zero commission models, on the one hand, they add unnecessary volatility in the form of price cycles due to the failure to commit to transparent transaction costs ex ante. It turns out that they can be more or less efficient, and what I didn't talk about, they can also yield to more or less revenue than transparent transaction costs, where this is going to depend on the risk attitude of traders. And on the one hand, something that's been kind of like a folk result already is that these payment for order flow and zero commission models, they need unsophisticated traders in order to remain profitable, because strategic market entry could lead to no revenue or even market failure. Yeah, thank you.